HACARUS webinar series. My name is Adrian Sosna, and I'm going to walk you through Explainable AI and its significance. Before we get into Explainable AI, let's talk about the evolution of machine learning, which is the core of AI. Machine learning has a long history and started with simple thresholds and rules. Over the years, analysis using mathematical models developed, leading up to deep learning, which combines the inputs and parameters of thousands to create complex predictions. Assemble learning, a further development, creates multiple deep learning models and uses the result in combination. Recently, a method called meta-learning has been developed, which is a method for learning the process of a deep learning model's learning. In essence, this allows for model creation and training to be done even when there's not sufficient amount of data. This has enabled us to learn without the necessity of a huge amount of data. As a result of the significant development of machine learning models, the following paradigm shift has occurred. Machine learning is now expected to play an active role in unprecedented areas such as autonomous driving and drug discovery. It will also be possible to handle multiple types of data combined, such as image data, sound data, or text data. Concerning hardware, recent years have seen massive development in dedicated deep learning hardware such as GPUs and TPUs. Due to this paradigm shift, AI using machine learning has become the center of attention. As you may have noticed, the title of this slide includes non-linear model. Deep learning is said to be non-linear. So what is non-linear? In a linear relationship model, it's easy to recognize that the output either increases or decreases as the input increases. However, with a linear model, with a complicated shape, like the one in the middle of this slide, it's not clear how this function behaves, what the function actually is. Furthermore, deep learning becomes far more complicated than what we can understand because the parameters become more complicated with tens of thousands or even millions parameters intertwined. This complexity is the source of the high capability of deep learning, but there's also some problems that arise due to its complexity. As you can see, the more complex the model, the more difficult it becomes to control it. You will not know what kind of calculation is being done internally, and the transparency of the model is lost. Furthermore, undesired features underlying in the data can be amplified as well. Let's look at some examples of these problems. The leftmost image is an example of Google's image classification service. Now, the image classification service is supposed to provide a label underneath each image to give a direction of what is being depicted. However, in this image of a black man and woman, it's been wrongfully labeled as gorilla. Now, from the user's point of view, this is a terrible experience, and it's clear that this is not acceptable. The image in the middle is an article where male candidates unnaturally received higher ratings than female candidates when Amazon recruited people using AI. This is due to the fact that biases have influenced the AI, and many men currently have higher jobs or better positions. The image on the far right is an image from an accident where a person crossed a street in the middle of the road without a pedestrian crossing. This person was killed by the Uber self-driving car, which was driving on a public road. The brakes could not be applied because the rules of the AI model could not assume that a person would take such actions. In this way, although highly capable AIs have been created, the information that should not be amplified is amplified, and problems do occur due to these control issues. We want to understand why. What is the reason AI makes a decision? And what do we need to understand that? Well, of course, the answer is we need explainable AI. In recent years, As complex models based on deep learning have increased, this area has gained more and more attention. The definition of explainable AI is a concept that originated in a study by the US DARPA. They defined it as a technique or a study where the model prediction is human understandable and sufficiently reliable. Explanation and interpretation are important words related to explainable AI. Explanation refers to the description or the ability to describe in human readable terms. This is defined in a paper by Doshi Velesh and Kim. This paper is frequently referred to in Explainable AI, so if you're interested, please check it out. The term interpretation is defined as an understanding through interaction between humans and agents. This means that humans can interpret AI results and give feedback. Therefore, by understanding explanation and interpretation, and understanding the model well, you can understand the risks and take countermeasures. Google has defined the purpose of explanation as follows. It's about information, greater transparency, debuggability, and finally, auditability. Let's take a closer look at the events that require explanation. When an abnormal event or an unexpected event occurs, people want to know the cause. If that comes with a cost, controlling that cost has to be taken into consideration. However, explanation is necessary in order to understand the event. An event structure is shown in this diagram. Let's say a person breaks a plate. An event like this, where you want to know what the cause is, called fact. That person will want to know why they broke the plate. It is explanation that gives this reason, and in this case, the explanation would be he was in too much of a hurry. On the other hand, in an event with no certain problem is called foil. In this case, if you do not break the plate, you still want to know why. In this case, the explanation would be that he was not in too much of a hurry. By comparing the expectations and explanations of fact and foil, you can compare normal and abnormal events. Thus, you can evaluate AI. So how can we achieve explainable AI? There are two main approaches. The first one is to add explanation to a complex AI model, such as deep learning. What we do then is add the ability to interpret the internal calculations that are too difficult for a human to interpret. The next approach is to use a model that is easy to interpret from the first place. This second approach does not require any clarifications or changes, but it also tends to be less accurate because the model is less complex. In this video, we're going to focus on how to achieve explanation from a complex AI model. There are methods to evaluate explanations. Let's first look at Shapley value. Shapley value is something that originated from game theory, and it is a value that evaluates how much the feature used for learning contributes to the prediction. Let's take a look at the figure below. For example, let's say you've trained a machine learning model using 3 features, A, B, and C. After that, we calculate the contribution of each features in all contributions and permutations. This is a value such as A equals 10 written on the far right of the figure. This contribution is calculated for all combinations and permutations, and the average is calculated as the final Shapley value. By doing this, it's possible to calculate how much each feature contributed to the AI model. In other words, it's possible to understand which features the AI prioritizes. The second method I'll introduce is around integrated gradients. Skipping the detailed formulas, in this example, the target is an image, so a black image is the baseline. When the image is changed from this baseline to the original image of a child, The AI model will extract the parts that is the most noticeable, that is, the part that greatly contributes to the change in the predicted value. This creates the middle image in this example with the integrated gradients. Actually, in this example, when an AI model classifies the most leftmost image, this image is wrongfully classified as a sandal. When I look at the original image, I'm wondering why this happened, even though it's clear the original image is a child. If you look at the outline of the image of the integrated gradients, you can see that it looks like a vertical red sandal. This will allow you to interpret why the AI model produced a result like this one. As mentioned previously, a baseline is essential for accurate explanation. Consider our previous example with A, B, and C. Let's say they are employees and salary packages according to their degree of contribution. We would generally think an empty set as the baseline, but what if A worked first and then B and C started working? A set containing A should then be the baseline. Therefore, a baseline should reflect the FOIL we want. There are two typical baselines. Uninformative baselines that do not show any information. These are mostly the equivalent to FOIL. Things like not smashing the dish or an image with a random grayscale pixels are examples. The other type is informative baselines. The use of certain facts as baselines can highlight important explanations for the actual observed output. In this example, this would be A started working first. In the case of a question such as, why did my credit score drop by 50 points from last month, is considered effective to use the state of 1 month ago as the baseline. Up until this point, the focus has been on explanation. Of course, giving explanations is very effective to evaluate the result of the models. However, explanations have limitations. In a nutshell, we can only observe the approximated results and that the given results do not represent the overall behavior of the model. You can see what the deep learning model focuses on, but you can't understand why the model decided to focus on that certain part of the model. Explainable AI is not perfect. It all comes down to how humans utilize it. In other words, it depends on how we interpret the results and the explanations given. In this example, if we use a linear model to predict the future of men's and women's 100 meters time scores, by 2156, women will overtake men. This is probably a biological impossibility. However, because the model predicts linearly, the strange phenomenon occurs. This example is easy to understand, but the same happens when using complex AI models. Ultimately, it all depends on how we interpret the AI and how humans utilize explainable AI in order to do this. In other words, explainable AI is not a substitute for AI. It's more of a tool that helps us understand what's going on. It's also clear that it's important to visualize sufficiently to help that interpretation. In this example, using integral gradients, the image to the very left is far less clear. Now this is related to that the explainable or contributing factors are not evenly spread out. If we exclude the 99% that does not contribute much to the explanation, it's much easier to see the visualization where the AI has focused on, in this case to the very right. Until this point, the methods and concepts of explanation has been the main focus, but we will now take more of a look on its practical use. The first is detecting data leakage. Data leakage is when data that cannot be used for learning is mixed into the data set. In this example, an image diagnostics model that's been created to discover new diseases from X-ray images is presented. We were able to obtain very good accuracy in the test results. It was so good that we wanted to use explanation to find out why. What we actually found out was that the data contained images in which doctors drew lines where the disease existed. In other words, the model learned the lines drawn by the doctors, not the actual occurrence on the image. In reality, such data cannot exist and cannot be used for diagnosis because the AI system is supposed to perform this function before the doctor's diagnosis is made. By using explainable AI, it's possible to find the part that AI is paying attention to and see if such events need to be changed. This is another practical example. In this case, AI is used to assist in image diagnosis. It's been reported that by emphasizing not only the diagnosis results, but also the pixels that contributed to the diagnosis, doctors' sensitivity towards the correct diagnosis has improved. Explainable AI is used to display pixels that contribute to the diagnosis. We also know that collaboration of doctors and AI together yield better results than each on its own. However, it must be taken into consideration that the AI diagnosis of no disease may have a harmful effect. Explainable AI has become essential as the number of highly accurate and complicated AI models increases. Explanation of AI is possible using indicators such as shapely value. However, there's a limit to the explanation. Explainable AI is not a replacement for existing AI, but it's an additional tool to help bridge the gap between human user and machine learning based model. Thank you for tuning in to this webinar. We'll be back in 2 weeks with a new topic. I look forward to seeing you then. Thank you.